Let's discuss the topic of deadlock in operating system. So deadlock happens when two or more processes wait for one event which was never going to happen. In this resource allocation graph, you can see there are two resources and two processes. Resource R1 is allocated to process P1, but P1 requests the resource R2. Similarly, this process P2, it requests resource R1, but R2 is allocated to it. Okay, so in this case, both the request of P1 and P2 is never going to happen. Okay, so in this case, there becomes a circular deadlock because this P1 can complete only when it gets R2, but R2 is allocated to P2. And this P2 will get over only when if it gets R1, but R1 is allocated to P1. So in this case, this P1 and P2 will never get completed. The process P1 and P2 will never get completed. So the deadlock condition occurs. And there are conditions for deadlock. First one is mutual exclusion. Second one, no preemption. Third one, hold and wait. And fourth one is circular wait. So these are the four conditions of your deadlock. Next is about resource allocation graph. So the graph which we saw for deadlock is known as resource allocation graph. And as every graph, this also has a vertex and edge. Okay. Here the vertex are process vertex and resource vertex. So process vertex are your processes and resource vertex you can have single instance or multiple instance. Single instance means single resources like your CPU. And multiple instance means your registers where you'll have more number of your resources. Okay. And your edge. Your edge is also of two types. Next is your edge. Your edge is also of two, assign edge and request edge. Okay, assign means your resource is allocated to your process. And request means your process is requesting a resource. Okay, so these are the two types of edges. Next is circular wait for single instant. Okay, so this is one RAG. So you can see that R1 is allocated to P1, but P1 is requesting R2 and R2 is allocated to P2, whereas P2 is requesting R1. Okay, so this is one case of circular wait where this is never going to happen. Okay, this is a single instant case. It means a single resource is there. Okay, so this is the table which we have put for that graph. Okay, there are two processes P1 and P2 and its allocation and request graph is given here. Okay, request table is given here. Okay, and this is the availability. Okay, so this is the availability. As you can see, R1, R2 is not available. Okay, as from this table, R1, R2 is not available. So it is a clear case of deadlock. Okay. Have a single instant and circular wait. If you have single instant and circular wait, there is 100% chance of deadlock. Next is for multiple instant, that is multiple resources. Here you have this RAG where R2 has two resources, okay, and R1 is one resource. R1 is allocated to P1, whereas R2 one is allocated to P2 and another R2 is allocated to P3 and P2 is requesting from R1. So in this case you can see this P3 is not requesting from any resources, okay. So in this case you have multiple instant and circular wait. There is no particular condition that it will be ending in deadlock. Okay, it can end in deadlock or it cannot end in deadlock. Okay, so this is the condition.